Now in this video I'll create a layout for button. To do this I will use layout Excel. I'm going to launch layout Excel, create new. Okay, the layout Excel window has been opened. Here there is a button called generate all from source. I will generate pins from the schematic. So I will, as I have no P cells here, so I will not generate any instance from the schematic. I will generate only IO pins from the schematics. No PR boundary. I will not generate it now. And the IO pins, I want it to be made of metal 1 drawing. So I'll choose metal 1 drawing, apply. Now OK. It has been generated. The 4 pins of the schematic. I want to change some display settings. To do this I will go here and change the stop level from 32, minor spacing to be 0.005 and major spacing to be 0.05. Apply, and these tick signs. Okay, now first I have to make it N-MOS. To make an N-MOS, I will first draw a P-OL. I will first select P-OL drawing layer, not net layer, drawing layer from here. Now I will press R, which is the shortcut to draw rectangles. And I am pressing R and drawing a rectangle. Another thing is, it is helpful to make this design rule button checking on. I am checking this one on, this one on, and this ones. I'm checking these ones on. This will dynamically show me error in DRC errors or design errors. I have first drawn an POL. Now I will draw an active layer. I'm pressing R, selecting active from here. I'm drawing active region here. Now I have to make a polysilicon gate. To do this, I'm selecting poly layer from here, pressing R and drawing a polysilicon layer above the active region. Now I'm going to select this, pressing Q to find its dimension. Now, as you can see in the schematics, the width of our N-MOS is 90 nanometer and length is 50 nanometer. In the layout, all the units are given in micrometer unit, so I choose its width to be 0.09. Its height would be 0.09 micrometer, means 90 nanometer, and width will be 0.05 micrometer or 50 nanometer. Okay, the gate has been formed. Now adjust this active region with this gate. I am pressing the key S, which is the shortcut for stretching a layer. I am selecting, hovering over this border and selecting this layer and stretching it down to the edge of the polysilicon gate. We can also use a scale tool to measure the distance between the borders. The shortcut for a scale tool is K. I pressed K in my keyboard, and if I want to measure the distance between these 2 points, then I will select this line and this line, and it has shown me the distance between them. Okay, now I don't need this, so I am going to delete it. Now I will place the contact for source and drain regions. To do this, I am pressing O, which is a shortcut to create pairs and contacts. And since it is N-MOS, I am going to connect metal 1 layer to the an implant layer, which will be included later on, the N implant layer. I'm choosing M1 here, hide. I want to place it as close as possible to the gate. It's giving that there should be minimum distance of 0.09 micrometer between the contact and the gate. So I will place it here where there will be no error. Yes, there should not be any error here. Again, in that side, I'm placing it here as close as possible without making any errors. Now, adjust the active regions within this. I'm pressing S to stretch this active layer, stretching this side to this one, this border. Okay, done. Now I want to stretch this P-OL layer. Before stretch layer, I want to draw the N implant layer over this active region. I'm selecting N implant and drawing a rectangle as just the same size as the active layer. Just above the active layer, I'm drawing the N implant layer. All the layers should be drawing layer, not the net layers. Okay, drawing an implant layer is completed. Now I'm going to stretch the POL closer to this N-MOS. So I'm pressing S and stretching this boundary as close as possible without making any errors. Okay, done. Now this one as close as possible. Okay. Now I have to place another contact to the POL to connect the body to the ground. So I'm pressing O and here I'm choosing P-tap. I will place this P-tap layer as close as possible to the N-MOS. I'm placing it here. Okay, now I'm stretching this POL closer to here. Okay, done. Now our N-MOS is almost completed. Now I want to draw a P-MOS. To draw this, I have to first draw an N-OL. I will draw N-OL here. Select the N-OL layer. Pressing R, creating rectangle. N-OL. There is a design rule. What should be the minimum distance between this POL and N-OL? We have to place this N-OL at least that distance which satisfies the design rule. And right now I am now just making the P-MOS, then I will just shift it there. First I have made the N-OL, then I will make the active region. Now I will draw the polysilicon gate. Now the P-MOS is 50 nanometer. And I choose its width to be 180 nanometer. Okay. So I change the parameters of this one. The width to be 180 micrometer, 0.09. sorry, the width is to be 50 nanometer, 0.05, at the height to be 180 nanometer micrometer, 1.180 micrometer or 180 nanometer. Width is 0.05. Okay. Okay, then now I'll just stretch this along the polysilicon gate, these layers. Okay. Now I'll place the contacts for the source and drains. Pressing O. Now, as it's P-MOS, I will choose M1 to P contacts. I will try to place it as close as possible without making any errors. Escape. You can press undo the last one. Okay. Again pressing O and placing it closer. Okay. Now after it's done, I will place the P implant layer over it. I'm choosing P implant, pressing R, drawing a P implant layer just over the active region. Escape. I'm pressing S to stretch this layer to the edge of the active region. Okay. Now the P-type in P-MOS anvil should be connected to the VDD, so I'm going to stretch the anvil first, then placing a contact to connect it to the VDD. I'm just stretching it out to place the contact. Now I'm placing O, and I will use an N tab because I have to connect this anvil to the VDD. So I'm placing it here. Okay. Now stretching it closer to this. Now our P-MOS drawing is almost completed. Now, since we are using the VTG devices, the default is VTL device, we are using here VTG devices. So finally, we have to use the VTG layer to declare our transistor as VTG. I'm choosing VTG drawing layer here, pressing R and hovering over this whole oil structures to declare a MOSFET. I have to stretch it down on the edges. Okay, escape. To adjust, I'm pressing S and stretching it to the edges. Now it's been almost completed building the transistors. Now there is a design rule. The minimum distance between the N-oil and P-oil at different potential should be 225 nanometer. So to do this, I'm using a scale to measure the distance. I'm pressing K in my keyboard, drawing a scale from here. The minimum distance is to be 0.225 micrometer. placing a scale of 0.225 meter, 225 nanometer here. Now I'll just select this P-MOS, press M, pressing N is to move it. You can move it just horizontally and vertically. First I'm moving it horizontally. And I'm again pressing M. I'm again pressing M to adjust it to the 0.225 nanometer distance. Get down. Now I don't need this. I'm deleting this scale. I'm aligning this N-MOS and P-MOS. Actually what I can do is I can place this contact to this side so that these two gates are aligned. It will be helpful to create the paths later on. So I'm selecting this one and pressing M and moving this contact to this. Now I'm stretching this escape S to stretch it, placing it here, placing this left to this one, and stretching this one up to this. Okay, done. I will just now align it with the N-MOS, selecting all and moving it horizontally. Approximately aligned. Now making of N-MOS and P-MOS has been done. We have to just connect the ports now. First I connect the two gates. To do this I am clicking P in my keyboard to create paths, and the path should be made of polysilicon layer. I'm selecting poly here. From the middle of this polysilicon, okay, you can connect it up to this. If we double click here, the path will end. Double clicking here to end the path. Now there are slight misalignments. I'm pressing escape button, and now I'm selecting this P-MOS. Now I'm pressing M, clicking here at any place and slightly moving the P-MOS to align it with the path. Okay, I'm again clicking it and movement is completed. It is aligned. Okay, done. Now what we have to do is to connect the drain of N-MOS and source of P-MOS together. So I will go and connect this these drains with these drains, drain of N-MOS and drain of P-MOS. So I'm pressing P. Now the path I want to make it with the metal 1 layer, so I'm selecting metal 1 here. Now at the middle point I'm clicking one and going with this, and at this edge I'm double clicking to end the paths. So you can see there's some slight misadjustment, So I move this contact slightly. I'm selecting this contact, pressing M, clicking once, left clicking once, and slightly moving the contact, and it has got aligned. Okay, done. Okay, now source and drains are the drains of the N-MOS and P-MOS are connected. Now I want to create a V out pin here, V out pin. So I'm going to create another path from here. I'm pressing P and selecting this edge up to this one and double clicking it here. Here I have already generated the pins. I'm selecting this P out pin, pressing M, moving it here to here, selecting, pressing M, moving it here up to this point. Placing it here. Okay. Now I want to put the pin here. I have to put the pin make of metal layers. So I want to metal one layer. So I want to include a peer here. The peer will be metal 1 to polyphere, metal 1 to polyphere. I'm placing it here. Just placing it middle. The middle, yeah. Escape. Now just select it and delete. Okay. Now create a path of metal 1 layer. P. Select here. Then go up to this. Okay. Now I want to place the P in here. I'm selecting it, pressing M, and moving it to here. Okay. I'm pressing M, and move it to here. Align it to and go further. Okay, done. Now I have almost done. Now I have to draw the VDD and PSS scripts. To draw these, I will make this with metal 1 layer, so I'm creating another path here. First I will draw, then I will adjust. Escape P to create path, double click to end the path. Now select it, press M to move. I'm moving further so that there is no DRC error. Okay, now I have made the ground rail. Now select it, press C, give one click, and it will be copied. I want to make the VDD grid, so I want to place it here. Okay, now I want to stretch it little bit. I press this edge and one click. Then I will select this edge and one click to end this. Okay, now I will place the VDD and VDA ground pins to the rails. I'm selecting the ground. pressing M and moving it near the ground rail, over the ground rail. Again pressing M and moving it over it. Done. Now I'm selecting this one, pressing M and moving it to the VDD. Okay, done. Now I'll just connect the VDD to the source and ground to the source of N-MOS, VDD to the source of P-MOS. To do this, I'm pressing M, creating a path from here. There is some misalignments. I'm again pressing P and up to this point. Double click to end the path. Now again from this point, drawing it again. Double click to end it. Okay, done. Now connect it to the grounds. Okay, now I'm pressing escape. Now our layout is almost complete. Finally, I have to create the labels for the wires. So I'm going to create label. First, I want to create the V in. Right. Escape. I'm again going to create label. I want to change the height to 0.01. And if I use current layer should be of metal. I place the P in over here. Escape. Again, I'm going to create P. Press P out. So I'm not creating. I have to create levels. Create levels. Let's P out. I'll place it here. Escape. Create pin. Create level. VDD. Alright. Pressing VDD here. Escape. Create level. The level should be made of metal 1 layer. If my pins are on metal 1. Alright. Placing the ground here. Escape. Now our layout is almost completed. I'm just saving. Now to run the DRC, I'm going here, calibrate, run NMDRC. The DRC into the rules folder, rules manual, just load it. Inputs. Okay, just run DRC. If there are no errors in your design, then all will be green checked and the number of results will be 0. But if you have an error, there will be some cross marks or red cross marks. You have to check it down. Okay, I'm selecting this. Minimum spacing of active areas is 0.08. So I'm going to find out where is the problem. I'm selecting it, right click, highlight. In the layout, it's been zoomed. The place of area, the minimum distance between the actives. So I am moving this contact slightly further from this active region. To do this, I'm going to select this. I'm going to select this to this, pressing M and slightly moving it. And you can see in the design rule, it suggests that the minimum distance between the active layers should be 0.08 micrometers. So we can place a scale here, move it to 0.08 micrometer distance. To do this, I'm pressing K here. I'm doing it right. Okay, we have to move this contact up to this point. So I'm selected it, pressed M and move it up to this point. Just control and selecting control and selecting the things, selecting these, control and selecting the scale so that the scale doesn't move. I'm pressing M and moving this contact up to the edge of this scale. Okay, done. Now I'm going to just stretch the layers up to this. Scale and stretching these layers up to this point. Okay, done. Now the second error, the same error in the N-MOS side. So here the rule suggests the minimum distance is 0.08 micrometer. So I'm again placing, I'm deleting this scale from here and I'm placing a scale here. Pressing K in my keyboard and draw a, pressing K in my keyboard and draw a scale of 0.08 micrometer. Now again I'm choosing these, control, pressing this scale, so the scale is not selected. Now pressing M and moving this one up to this point. Up to this point, so that the distance between the active regions is 0.08 micrometer. I'm just selecting the scale and deleting it. Okay, I'm stretching the layers of escape. Almost completed. Save. Now I can run the DRC. Run DRC. And you can see that there are no results found. That means my design is DRC clean and there is no red signs here. So my design has no design rule errors. Now I have to check whether my layout corresponds with the schematic. To do this, I have to run the LVS. To run LVS, in the LVS, in the rules, I have to load the rules and run LVS. If everything is correct, then it will give the green signal and it will show here the correct written here. If my schematic corresponds with the layout. If there are any errors, the errors will be shown here, and we can find out the errors by seeing the schematics produced from the layout. To do this, you can click on the schematics, and you can see two schematics. One is from the source, or the schematics netlist and the schematics that I got from the schematics, and this is the netlist and the schematics produced from the layout. You can just select it and right click it, and you can see the internal circuitry. You can select it and right click it and see the internal. You can just move the scroller here. If the schematic produced from layout and the schematic that we have provided are exactly same, then there will be no LVS error. If there are an LVS error, you will see discrepancies between these two circuits, and finding out these discrepancies, you can correct that in the layout. In this way, we can check the LVS errors. For example, if there is any error, we can intentionally make an error here. For example, we want to delete this path. Okay, then say that if we run LVS now, I'm going to run LVS now. You will going to find some LVS error, some LVS mismatch. Yes, it's showing it's incorrect. Now we have to find out where the problem is. To do this, I'm going to schematics, clicking it, clicking this one, double clicking this one, moving the scroller. Here you can obviously see that everything is okay, but there is no connection between this point and this point, where in our schematics there is a connection here. So what we have to do is we have a missing connection between this node and this node. We have to correct it in the layout. So we're going to do that. So here there is no connection, and that's the error the LVS is showing. So again, we are going to create a path from this point to this point. There is little misalignment. I'm going to select it, pressing N and moving over it. Okay, done. And I am going to save it. Now again, if I run the LVS, we will get hopefully no errors. So this time there is no errors, the schematics are same, and you can also check the netlist here, the source netlist here. These two netlist also should be same. There is no DRC. Here you can see the length and width. The length and width should exactly in the schematic is provided, and should match between the schematic and the layout. In this way, we can draw the layout and check the DRC errors and LVS errors.